Okay, so part three of inequalities, linear and absolute value. We're going to look at the absolute value inequalities. And so we're going to solve absolute value inequalities in part three. Let's kind of review a couple of things. If you look at this graph, and let's say this graph, the solutions are between, let's say, 5 and, negative 5, that's negative 5. And let's say, and let's do bracket here, let's say 5. Okay, so if the solutions, so if I graph everything between negative 5 and 5, remember in terms of an inequality, in terms of inequality notation, and using the variable x, that means that all of my x's, all of my solutions, if this were solving an inequality, all of my solutions will be between negative 5 and 5, meaning that x has to be less than or equal to 5 because of the bracket, so equal sign, and at the same time it has to be bigger than or equal to a negative 5. Alright, so this right here in terms of an inequality means this. So x is between negative 5 and 5. Alright, so that's how we would write this graph as an inequality. If I look at this one, and let's say this is negative 5 and this is 5, but instead I'm looking at the graph, and I'm going to use parentheses this time. I'm looking at the graph to the right of 5, and I'm looking at the graph to the left of negative 5. And so in terms of an inequality notation, this means that, let's do this one first, this means that x has to be less than negative 5, or, notice the word or x has to be greater than 5. Alright, so x has to be less than negative 5, that's what I shaded, or my solutions can come from this part of the graph where it says that x has to be greater than 5. Alright, so this is an or statement, okay, not an and statement, that's an or statement. So you'll notice where you have two separate intervals like this, two separate graphs, you can use the or statement. Notice right here, that's an and statement. Notice when I read it as x has to be less than or equal to 5, and at the same time, it had to be greater than negative 5. So everything between negative 5 and 5 is a solution to the statement I just made. X has to be less than or equal to 5, and at the same time, it has to be bigger than or equal to negative 5. Alright, so those are the two things that you're going to need with solving absolute value inequalities. Now, to get you to understand how to solve an absolute value inequality, let's look at this statement right here. Let's suppose we want to solve, and this is a simple one. And the idea is not for you to memorize what it's supposed to look like. The idea is for you to think about in your mind, well, what does it look like in my mind? Does it make sense? Don't memorize this. You're not going to, chances are you won't remember how to solve an absolute value inequality if you memorize, because you have a lot of other types of equations and inequalities to deal with in this course. So let's start with a simple one, and this is one that you should always think about. Let's say we had the absolute value of x is less than 3. Okay, so the absolute value of x is less than 3. Now the idea is to rewrite this without the absolute value bars. The idea is to rewrite this without the absolute value bar. Okay, so let's think about what the solution would be in terms of the number line. Alright, so whatever x is, whatever the value of x is, the absolute value of that has to be less than 3. So if you think about it, 0, if you look at 0, 0 is a solution because the absolute value of 0 is 0, and 0 is less than 3. In fact, if you think about it, so is 1/2, so is 1, so is 1.2, so is 1.76, so is 2.00008, 2.8999, 2.999999, all the way to 3. And notice there's, I can't use 3, by the way. Notice I'm saying I can't use 3. Make sure you understand why. Because if I plug in 3, the absolute value of 3 is 3, but 3 is not less than 3. 3 equals 3. So I've got to use parentheses. So so all these so far is a solution. Okay? Now, remember I tried 0 and positive numbers up to 3. 4 is not going to work. So make sure you understand why I ended up stopping at this boundary 3 with parentheses though. 4 doesn't work because the absolute value of 4 is 4, but 4 is not less than 3. But let's try negative 1. Does negative 1 work? Does negative 1/2 work? Does any number between 0 and negative 1 work? Well, if I plug in negative 1, the absolute value of negative 1 is a positive 1, and 1 is less than 3. Well, what about between negative 1 and negative 2? Do those numbers work, or those solutions? Well, if I plug in, let's say, negative 1.5, the absolute value of negative 1.5 is positive 1.5, and 1.5 is less than 3. In fact, I can go all the way down to a negative 3. Now, I can't use negative 3 because if I plug in negative 3, the absolute value of negative 3 is a positive 3, but 3 is not less than 3. 3 equals 3. And that's where I stop. I can't go any further because if I use, let's say, negative 4, just like I did 4 a while ago, negative 4, the absolute value of negative 4 is 4, but 4 is not less than 3. So in fact, my solutions are between negative 3 and positive 3. Now, here's what I want you to think about. Okay, so in your mind, you know that the absolute value of less than 3 is the solutions are bounded within one interval. See, that's just one interval. So it's negative 3 and positive 3. Now, in terms of an inequality notation, this is what it looks like. You're going to say x is less than 3, and at the same time, it has to be bigger than negative 3. And that's what you're going to think of. So a absolute value less than, you're going to write as one compound statement that looks like this. Because if it's less than, based on what we talked about, the absolute value of x has to be less than 3. Well, the only numbers that work are between negative 3 and 3. If I go beyond those numbers, nothing else works. 5 doesn't work, negative 8 doesn't work, and so on. All right, so absolute value less than looks like this. So what I want you to think about now is this. Well, what if I had, let me go to the next one. So what if I had this? Let's write this as number 1, and let's write this as number 2. All right, suppose I had the absolute value of x plus 5 is less than or equal to 6. All right, and notice this is an absolute value less than. Absolute value less than. So remember, with absolute value less than, you write as one statement. So this expression right here, this right here, goes in the middle. And so you'll say x has to be less than 3, and at the same time, it has to be bigger than a negative 3. You just take the opposite of this number. So based on what we just talked about, what this means, notice absolute value less than, you're going to take this expression here, so you can, remember the idea is to remove the absolute value bars. Rewrite without absolute value bars. Okay? So you're going to say x plus 5 has to be less than or equal to 6, and at the same time, it has to be bigger than or equal to you take the opposite, negative 6. And so there's your compound statement. So you wrote it without absolute value bars. And then all you do is just get the variable x by itself in the middle. So you can subtract 5 from all parts. Negative 6 and a negative 5 is a negative 11. It's less than or equal to, combined like terms, that's x. It's less than or equal to 1. So your solutions are between negative 11 and 1, and including negative 11 and 1. So if you try, let's say, negative 10. Negative 10 is in here. Negative 10 plus 5 is a negative 5. The absolute value of negative 5 is 5. Is 5 less than or equal to 6? Yes. If you try, let's say, negative 4 is in here. Negative 4 plus 5 is 1. The absolute value of 1 is 1. 1 is less than or equal to 6. If you want to try 2, 2 is not in here. Okay, so let's see why 2 is not in here. 2 plus 5 is 7. The absolute value of 7 is 7. 7 is not less than or equal to 6. 7 is greater than 6. All right, so those are your solutions. So my solutions are between negative 11 and 1. And if you were asked to graph it, so here's negative 11, here's 1, bracket at negative 11, bracket at 1, and you're shading in everything between them. Okay? In terms of an interval notation, you're going to say bracket negative 11, comma, 1 with a bracket. So there's the graph. So remember, you graph the solution set. So my solutions are between negative 11 and 1. And this is interval notation. And this right here is inequality notation. All right, so when you solve an absolute value inequality, you're going to rewrite it without absolute value bars. So you're going to rewrite it as an inequality notation. That's all you do is just take this expression, rewrite it, and then you're going to bound it between this number and the opposite of that number. All right, number 3. Suppose we had 2x minus 5 plus 3 is less than, let's say 9. 9. So the absolute value of 2x minus 5 plus 3 is less than 9. Okay, now the difference between this one and the previous one is that in this one, the absolute value bar is not by itself. So the first thing you want to do is get the absolute value by itself. First thing, get absolute value by itself. Okay, and so I'm going to subtract 3 from both sides. Combine like terms, I get the absolute value of 2x minus 5 is less than 6. Now, you're going to rewrite it without absolute value bars. So remember that you're going to rewrite it as a compound statement. Absolute value less than, rewrite as a compound statement. As a compound statement. Compound inequality. All right, so one statement. So you're going to say this. You're going to take this expression inside, 2x minus 5. You're going to say that has to be less than 6. And at the same time, it has to be bigger than a negative 6. And then all you do is get x by itself. So you say add 5 to all 3 parts. So negative 6 plus 5 is a negative 1. Is less than 2x. Is less than 6 plus 5 is 11. And then you get x by itself. You divide both all 3 parts by 2. And so your solutions are between negative 1/2 and 11/2. Not including negative 1/2 and not including 11/2 because there's no equal signs. So in the number line, so those are your solutions in terms of a inequality notation. In terms of the graph, let's say this is negative 1, this is 0, this is 1, 2, 3, 4, 5, 6. Okay. So in terms of the graph, negative 1/2 is between negative 1 and 0 in the middle. All right, so I'm going to use a parentheses because there's no equal sign, just like this. And then 11/2, remember 11/2 is 5.5. So that's between 5 and 6 in the middle, parentheses. And you shade in everything between them. Okay? So there's the graph. Now again, if you wanted to write this in interval notation, you'd say parentheses negative 1/2, comma, 11/2, parentheses. All right, number 4. Okay, so number 4, let's suppose we had, let's suppose we had this. Let's suppose we had 3 times the absolute value of x minus 6 minus 2 is less than or equal to, let's say, 7. Okay, so remember, you got to get the absolute value by itself, so I'm going to have to add 2 to both sides first. So I add 2. Combining like terms, I get 3 times the absolute value of x minus 6 is less than or equal to 9. All right, again, I got to get the absolute value by itself, so I got to, right now I'm multiplying by 3, so I got to divide by 3. So divide both sides by 3. What you do one side, you do the other. 3's divide out, and all you're left with is absolute value of x minus 6 is less than or equal to 3. And then, remember, since this is absolute value less than, you're going to write it as one statement. So you're going to rewrite it with the expression that's within the absolute value bars in the middle. You're going to say that has to be less than or equal to 3. And at the same time, it has to be bigger than or equal to the opposite of that, to the opposite of negative 3. And then all you do is get x by itself. So you're going to add 6 to all parts. Negative 3 plus 6 is 3. Combine like terms, negative 6 and 6 is 0. You're left with x. So less than or equal to 9. So there's your answer. So your solutions are between 3 and 9, if including 3 and 9 because of equal signs. In terms of a graph, you'd say 3, 9, bracket, bracket, and then shade everything between them. Okay, so that was absolute value less than. So absolute value less than, you write as one statement, one compound statement. So basically you're just going to take the expression within the absolute value bars and rewrite it with this number on the right and the opposite of that number on the left. Okay? Alright, so that was absolute value less than, or absolute value less than equal to. Let's look at this one now. Let's write this number 5. Suppose I want to solve absolute value of x is greater than 3 this time. So let's look at greater than and see what that looks like. Okay, so I'm going to just think of some numbers that works, and let's put on the number line. So here's 0. So my question is, does the number 1 work? Or does the solution 1 work? Oh, I didn't mean solution. Is 1 going to be a solution? Well, the absolute value of 1 is 1, but 1 is not bigger than 3. So no, I can't say that 1 is going to be a solution. What about 2? The absolute value of 2 is 2, but 2 is not bigger than 3. All right, well, what about 2.5? The absolute value of 2.5 is 2.5. 2.5 is not bigger than 3. Well, what about 3? Well, the absolute value of 3 is 3. 3 is not bigger than 3. 3 equals 3. But what about 3.1? Just a number right on the edge to the right. Let's say 3.1. Yes, that works. The absolute value of 3.1 is 3.1, and 3.1 is bigger than 3. So in fact, any number, since there's no equal sign, any number bigger than 3 works. Any number bigger than 3 works. Well, what about the negatives now? What about negative 1? Does negative 1 work? No, it doesn't, because look, the absolute value of negative 1 is positive 1. Positive 1 is not bigger than 3. Negative 2 doesn't work either. The absolute value of negative 2 is 2. 2 is not bigger than 3. In fact, if you think about it, what about negative 4? Well, the absolute value of negative 4 is 4, and yes, 4 is bigger than 3. In fact, any number less than, notice I use the word less than, any number less than negative 3 is also a solution. So notice how this one looks. Remember earlier we reviewed this idea here. So if you're given this graph and you want to write it in inequality notation, go from left to right. You're going to say x is less than negative 5, or x has to be greater than 5. So notice the word or. I did not use the word and. I use the word or. And means intersection. You're not intersecting anything here. Those are two separate graphs. So hence the word or. So when you look at this, my solutions, listen to the words I'm saying, my solutions for x, remember you want to rewrite this without opposite value bars. Rewrite without absolute value bars. So you're going to say, based on this, you're going to say x has to be less than negative 3, or the solutions, notice I use the word or, the solutions can come from this one. So the solutions can come from here, or the solutions can come from here. So x is greater than 3. All right, so notice how it looks. So this expression right here, the expression in the middle, you're going to say, you're going to rewrite it without absolute value bar. So you're going to say x is greater than 3, or you're going to say x is, and then you're going to reverse these. You're going to reverse these. So you can say less than the opposite, less than the opposite. So try to remember this graph. So whenever you're given an absolute value inequality greater than, think of this example here with the graph, and then think how it's supposed to look. That expression in the middle has to be less than negative 3, or it has to be bigger than 3. So based on this, if you have this, the absolute value of x plus 5 has to be bigger than, let's say, 6. All right, so bigger than 6. So based on this, you're going to, with greater than, absolute value greater than, you're going to write it as two separate inequalities with the word r. So you're going to say take this expression here. So you're going to say x plus 5 has to be greater than 6, or x plus 5 has to be less than, so one's greater than, one's less than. And then for the less than, you take the opposite. So it has to be less than a negative 6. So from here, less than negative 3, greater than 3. And then all you do is just solve each inequality. So notice I rewrote it. I rewrote this without absolute value bars. That's what you need to do. So now subtract 5 from both parts, from both sides. So you get x is greater than 1. And over here, subtract 5. You get x is less than negative 11. So my solutions in terms of inequality notation, you're going to say x is greater than 1, or x is less than negative 11. The graph, here's what the graph looks like. The graph, now remember, always go from left to right. So you're going to put negative 11 to the left of 1. So negative 11, 1. And so for this one, you're going to say that's less than negative 11, like this. And this you're going to say greater than 1, like this. So there's your graph. The interval notation, remember how to write this. Interval notation, you're going to say x, you're going to say, remember negative infinity, this arrow is going towards negative infinity, so you get negative infinity, comma, negative 11 with parentheses. Now, and if you use the word union, remember the word union, R and union go together. So union, so my solutions are the union of these two graphs. So it's the union of these two graphs. So you can say negative infinity to negative 11, parentheses, union 1 to infinity, like this. So make sure you use the word, or the symbol union. Okay, number 7, suppose you had this. All right, suppose you had the absolute value of 2x minus 5 is greater than or equal to, let's say, 4. The absolute value of 2x minus 5 is greater than or equal to 4. All right, so it's a greater than this time. So again, two separate intervals, two separate statements. So the first one, we're going to rewrite it without absolute value bars. So remember this expression within the bars. So you're going to say 2x minus 5 has to be bigger than or equal to 4, or 2x minus 5, and then you do the opposite, less than or equal to a negative 4. Okay, so one's greater than or equal to, one's less than or equal to. And then you just, for the less than or equal to, you take the opposite of that number here. And all you do now is just solve for x. You're going to add 5 to both sides, combine like terms. I get 2x is greater than or equal to 9. Divide both sides by 2. So x is greater than or equal to 9 halves. So there's one of your solutions. So my solutions, it's going to be bigger than or equal to 9 halves. Or they can also be, add 5 to both sides, combine my terms. I get 2x is less than or equal to 1. Divide both sides by 2. X is less than or equal to 1 half. So my solutions my solutions are either bigger than or equal to negative to positive 9 halves, or they are less than 1/2, less than or equal to 1/2. All right, in terms of a graph, remember you go from left to right, you go from smallest to largest. 1/2 is smaller than 9/2, so put 1/2 first, put 9/2 second. All right, so x is greater or equal to 9/2. Since there's an equal sign, you use a bracket. Looks like this. X is less than or equal to 1/2. Bracket. Looks like this. So notice two separate graphs. So the absolute value with the greater than or greater than equal to, two separate graphs. Two separate inequality statements with the word or. And then two separate graphs. Looks like this. So in terms of interval notation, again, remember how that's going to look. Let's do this in first. So you're going from negative infinity. Remember this arrow is pointing to negative infinity. And with negative infinity or infinity, you always use parentheses. So parentheses, negative infinity, comma, 1/2 with a bracket. Union. If you don't use the word union, it's not totally correct. You may lose a part of point or 2 points, however much it's worth. So don't forget the word union. So union, bracket, 9/2, comma, positive infinity. And remember, negative infinity, positive infinity, you use parentheses. All right. So at this point, remember, with the absolute value, let's do this one. With absolute value less than, one statement, one compound statement, and you get x in the middle. If it's greater than, two separate statements with the word or. For the greater than equal to, you rewrite it using that number. And then for the other part, you switch the reverse symbol, and then you take the opposite of that number. Okay? All right, number 8. Okay, so number 8, let's suppose we had this. Let's suppose we had, all right, now you got to be a little bit careful with this one. You got to listen carefully to what I'm saying. Let's suppose we had negative 3 times the absolute value of x minus 5 is greater than or equal to a negative 12. Greater than or equal to a negative 12. Okay, so you remember you got to get the absolute value by itself. All right, now listen carefully. So right now I'm multiplying by negative 3. I'm going to go ahead and rewrite this over. I'll multiply by negative 3. The opposite of multiplying by negative 3 is to divide by negative 3. So I have to divide both sides by negative 3. But remember, whenever you multiply or divide an inequality by a negative number, you have to reverse the symbol. So even though it's absolute value, inequality, I still have to reverse the symbol. I am dividing both sides by a negative number. So I've got to reverse this. So what happens, first of all, negative 3 divided by negative 3 is 1. So I'm left with absolute value of x minus 5 is less than or equal to, and then a negative 12 divided by negative 3 is a positive 4. And now I have the absolute value by itself, and this is a less than or equal to inequality. So that's one statement. Less than or equal to, one statement. So you're going to take this expression that's between the absolute value bars. You're going to say x minus 5 has to be less than or equal to 4. And at the same time, it has to be bigger than negative 4. All right, so notice the symbols, they're pointing in the same direction. All right, so don't make this mistake. A common mistake is this. Common mistake is this. X minus 5, remember the words, and that's where the mistake comes in. X minus 5 has to be less than or equal to 4, and at the same time, it has to be bigger than or equal to a negative 4. You notice those two symbols are not in the same direction. All right, so this is incorrect. Must be same direction. Okay, same direction. And now all you do is add 5 to all parts. And so my solutions are between negative 4 and 5 is 1. And that should be less than or equal to here. and then 9. So your solution is between 1 and 9. And you can check, let's just check one of them. So I'm saying that let's say 4 is a solution. And that's supposed to be an equal sign right here as well. 4 is a solution. So let's see why. 4 minus 5 is a negative 1. The absolute value of a negative 1 is a positive 1. A positive 1 times a negative 3 is a negative 3. And now the question is this. Is a negative 3 bigger than or equal to negative 12? And the answer is yes. Let's try 8. 8 minus 5 is 3. The absolute value of 3 is 3. 3 times a negative 3 is a negative 9. Is a negative 9 bigger than or equal to negative 12? The answer is yes. Let's look at 9. 9 minus 5 is 4. The absolute value of 4 is 4. 4 times negative 3 is negative 12. Is a negative 12 bigger than or equal to negative 12? Yes, it's equal to it. All right, so those are your solutions. In terms of the graph, remember you always go from smallest to largest. So here's 1, here's 9, bracket, bracket, everything between. Okay, so notice how the brackets look. So this one's pointing to the right. This one's pointing to the left. Okay, and the interval notation will be bracket. That's a bracket. 1 comma 9 with a bracket. All right. So let's look at one more. Let's suppose we had this. Suppose we had negative 6 is negative 6 times the absolute value of 2x minus 3 is less than or equal to, let's say, negative 18. All right. So, again, you got to get the absolute value by itself. So right now, multiplying by negative 6. The opposite is to divide both sides by negative 6. So divide both sides by negative 6. Now remember, if you multiply or divide an inequality by a negative number, which I am here, you've got to reverse the symbol. So negative 6 divided by negative 6 is 1. 1 times the absolute value of 2x minus 3 is the absolute value of 2x minus 3. Notice the steps. Do all these steps as presented. And since I'm dividing by a negative number, I've got to reverse this. So less than or equal to becomes greater than or equal to. Negative 18 divided by negative 6 is a positive 3. All right, now, this is absolute value. Now, the absolute value is by itself, but it is a greater than or equal to now. So that's two separate statements with the word or. Two separate statements with the word or. So you're going to, and remember, you're going to rewrite this without the absolute value bar now. So you're going to say 2x minus 3 has to be bigger than or equal to 3, or 2x minus 3. And remember, you just reversed all of these. Just reverse less than or equal to the opposite, negative 3. And so you're going to solve each of these inequalities. You're going to add 3 to both parts here. Combine like terms. I get 2x is greater than or equal to 6. Divide both sides by 2. One of your solutions says that x has to be bigger than or equal to 3. All right, so any number bigger than or equal to 3 is going to make the original true, the original inequality true. So let's say 4. If 4 is bigger than or equal to 3, let's see why 4 works. 2 times 4 is 8. 8 minus 3 is 5. The absolute value of 5 is 5. 5 times a negative 6 is a negative 30. Is a negative 30 less than or equal to negative 18? The answer is yes. All right, now let's do this one. Add 3 to both sides. Combine like terms. I get 2x is less than or equal to, and then negative 3 plus 3 is also 0. Divide both sides by 2. The 2's divide out, so I get x is less than or equal to. 0 divided by 2 is 0. And so my other solutions, are less than or equal to 0 also. So that's an OR statement though. So in terms of inequality notation, this is your answer, your solutions. In terms of a graph, This is what it looks like. Remember, two separate graphs with absolute value, with absolute value. We got the, you got to get the absolute value by itself. See, here it was less than or equal to, but the absolute value is not by itself. So you got to get the absolute value by itself before you think about, is it going to be one statement or two separate. Okay, so you got to get the absolute value by itself first. So again, you must get the absolute value by itself before you determine whether it's two statements like this or one compound statement. Okay, so the graph, remember you're going to put 0 first, smaller number, and then 3. So this says that x has to be bigger than or equal to 3. So right here, pointing to the right. This says x has to be less than or equal to 0, pointing to the left. There's your graph. Notice two separate graphs. And then the interval notation. So you just read this. So this is pointing towards negative infinity. So you can say negative infinity to 0 with a bracket. Union, remember the symbol union, bracket 3 to infinity. Okay? All right. So in terms of just the handouts that went with this section, so in terms of the handouts, so remember, the absolute value of u is less than c. You're going to write as one statement. So use between c and negative c. If it's absolute value greater than, you're going to write as two separate statements with the word or. One's going to be less than, and then the opposite of c, and the other is going to be greater than c. Okay? All right, so remember, absolute value less than, you're going to write as one compound inequality. Absolute value greater than, you're going to write as two separate inequalities. Okay. All right, so that's going to take care of this part, solving absolute value inequalities.